No. 1L22152 PE1, Series. Instruction Manual, Profibus function. Read and follow these instructions and all safety blocks carefully. Have only trained and qualified persons install, operate, or service this unit. Give this manual to the operator. For help, call your distributor. This is dummy page. Do not erase. Be sure to read instruction manuals before use. Thank you for selecting den arc welding robot all mega series. All mega series are the robots with high performance and various functions developed by making full use of the latest technology. Since the knowledge of welding peculiar to a welding machine maker is applied to both hardware and software, we are sure that each user can be fully satisfied in order to use the superior performance and the abundant functions safely and fully. Be sure to read the following instruction manuals including this manual and other attached documents, and understand the knowledge of the machines, safety information, and notes thoroughly. Instruction manuals related to the manipulator/per hour series, and the robot control unit FD11 are as follows. Standard manuals. Instruction manual type instruction. Manual no. Main contents. Quick start 1L21700 a point on safety, transportation and installation, turning the power on/off and manual operation, etc. Setup. 1L21700B. Safety precautions. Installing and connecting method. Starting up. Periodical inspection. Solution at the time of failure. Controller maintenance 1L21700K specifications of controller, explanation of each parts, and maintenance, parts list, etc. Manipulator NB4/NB15/NB6/NV6/NV20/NH51L11130. A specifications or maintenance of manipulator, parts, list, etc. Manipulator on V51L11312. A specifications or maintenance of manipulator, parts, list, etc. Manipulator on V166/NV210-1L11306. A specifications or maintenance of manipulator, parts, list, etc. Basic operations. 1L21700C. Explanation of manual operation, teaching, automatic operation, file utilities, backing up data, basic operations of arc/spot welding application, etc. External input/output 1L21700H interfacing method with external control device. List of I/O signals and start/halt the automatic operation, etc. Software PLC 1L21700J create program. Input/output relay lists. List of command words, etc. Control and maintenance function 1L21700L edit logging. User check, troubleshooting, etc. Application manuals. Instruction manual type instruction. Manual no. Main contents. Application manual arc welding 1L21700F basic settings. Functions for arc welding. Teaching. Technique, etc. Application manual spot welding 1L21700E basic settings. Functions for arc welding. Teaching. Technique, etc. Instruction manuals are available other than the above for each optional function that you have purchased. Notes 1. Specifications and information contained in these manuals are subject to change at any time without notice. 2. The screen display of a teach pendant shown in the manual are described as examples, which may be different from the actual ones. 3. Although we cautiously compiled this standard specifications to eliminate as much error as possible, we do not take any responsibility for damages resulting from neither direct nor indirect errors. 4. The manual is a part of robot products. When transferring or selling off a robot, be sure to append the manual. 5. No part of this manual may be reproduced without permission. 6. Prohibited altering or remodeling. Do not alter or remodel our products. You may get injured or have your equipment damaged because of fire, failure or malfunction caused by altering or remodeling the product. The warranty does not cover any altered or remodeled products. -1 notice. Notes on safety, before installation, operation. Be sure to read Chapter 1 Points on Safety in Setup Manual and other attached documents thoroughly and acquire all the knowledge of machines, safety information, and precautions. Furthermore, before maintenance, inspection, and troubleshooting, be sure to read Controller Maintenance Manual and Manipulator Manual and other attached documents thoroughly and acquire all the knowledge of machines, safety information, and precautions. If operating machines in a wrong way, the accident resulting in various ranks of injury or death, or damage may occur. In order to call attention to wrong handling, the following 4 ranks of safety notes: danger, warning, caution, and important, are provided. Danger. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of death or serious injury and where the degree of the urgency imminence of the warning given for the danger to occur is at the high end of the scale including high level danger, -2-. Warning. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of death or serious injury. Caution. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of minor injuries or of property damage only. The following symbol is also used for particularly important checkpoints. Important. This is a particularly important checkpoint. Note that even the matters which are described as caution can result in serious accident depending on the conditions. Be sure to keep the safety notes since they describe very important matters. The meanings of serious injury, minor injury, and damage described above are as follows. Serious injury, injury which has the after effect by loss of eyesight, an injury, the burn high/low, temperature, an electric shock, fracture, poisoning, etc., and that which requires hospitalization and long-term treatment as an outpatient. Minor injury, injury which does not require either hospitalization or long-term treatment as an outpatient. A burn high temperature, low temperature, and an electric shock. Damage, direct and indirect damage in connection with damage of property and equipment. Table of contents. Table of contents. Chapter 1 Outline. 1.1 What is the Profibus? 1-1. 1.2 The Profibus function of this controller. 1-2 1.2.1 Construction of I/O signals. 1-2 1.2.2 Performance table. 1-3 1.2.3 Installing location. 1-4 1.2.4 Hardware. 1-4 1.2.5 Cable connection. 1-5. Chapter 2 Needed parts. 2.1 Needed parts. 2-1. Chapter 3 Signal allocation. 3.1 The Fieldbus input/output signals. 3-1 3.1.1 When the software PLC is enabled. 3-1 3.1.2 When the software PLC is disabled. 3-1 3.1.3 Input/output allocation across channels. 3-1 3.2 Profibus signal allocation. 3-2 3.2.1 When this controller is used as a slave. 3-2 3.2.2 When this controller is used as the master. 3-2. Chapter 4 Operation. 4.1 Setting procedure. 4-1. 4.2 Profibus settings. 4-2 4.2.1 Fieldbus settings. 4-2 4.2.2 Profibus master settings. 4-3 4.2.3 Profibus slave settings. 4-5 4.2.4 motion check. 4-5 4.3 GSD file. 4-6 4.4 Backing up the BSS files and the DDB files. 4-7. Chapter 5 Fieldbus release. 5.1 What is Fieldbus release? 5-1. 5.2 Utilizing a Fieldbus release. 5-2 5.2.1 How to check the current status. 5-2 5.2.2 Connect/release by function command. 5-3 5.2.3 Connect/release by manual operation. 5-4. 1 Table of contents. 2. Chapter 6 Error detection. 6.1 Error detection on the Profibus module. 6-1. 6.2 Error detection on this controller. 6-3 1.1 What is the Profibus? 1-1. Chapter 1 Outline. 1.1 What is the Profibus? Profibus is certified according to EE 661,158 International Standard and EN 50,170 European Fieldbus Standard, and this is a network with reliability and openness proven in many factories and processes. By enabling network connections for limit switches, photo sensors, operation boards, robots and other industrial devices at a low cost, and by enabling logical access to the input and output network I/O provided by each of these devices. The Profibus improves communication between devices, which is difficult to achieve through hardware connections, and it enables diagnoses for each individual device. Up to 32 devices can be connected to the network, and the baud rate can be selected from 9.6 kilobit per second to 12 megabit per second, in accordance with the network size. The following diagram is an example where this robot controller is connected as a slave station to the Profibus. Terminating resistor, sequencers, sensors, I/O devices, PC master, robot body, terminating resistor, robot, controller, Profibus connection diagram. The Profibus function of this robot controller enables to be connected to the Profibus as shown above. This function also enables the robot controller to function as the master or / and a slave, and enables general input/output signals, such as I signal, to be operated via the network. The Profibus is a trademark of Profibus International. 1.2 The Profibus function of this control. 1-2. 1.2 The Profibus function of this controller. 1.2.1 Construction of I/O signals. The Profibus function of this controller supports up to 4 independent networks channels. In each of these channels, this controller functions independently either as the master or as a slave. Input and output. Operable by robot controller. Input I0000 I2047. Output O0000 O2047. Input I1 I2048. Output O10 2048. PLC. Input I0001 I0032. Output O0001 O0032. Input X0000 X0031. Output Y0000 Y0031. I/O board standard. Input X1000 X3047. Output Y1000 Y3047. Fieldbus. I/O board standard. When PLC is used. When PLC is not used. Input I0161 I2048. Output O0161 O2048. Fieldbus. Operation block diagram of the Profibus function. There are two ways of accessing the network I/O from this controller. When the software PLC is used, access is performed through the Fieldbus I/O with 2048 input contacts X1000 X3047 and 2048 output contacts Y1000 Y3047. When the software PLC is not used, it is performed through the logical I/O with 1888 input contacts I161 I2048 and 1888 output contacts O161 O2048. 1.2 The Profibus function of this controller. 1 to 3. 1.2.2 Performance table. Performance table. Item specifications. Number of channels. Maximum number of channels installed. 4. Master/slave can function as master or slave. Master or slave can be set independently for each channel. Number of inputs/outputs. A maximum of 1952 inputs, 244 bytes, and 1952 outputs, 244 bytes, can be used for all the channels. A total of 2048 general-purpose signals are provided for input and the same number provided for output. So most of the general-purpose signals can be covered. When the software PLC is used. Configuration. When this controller is used as the master, a dedicated configuration tool is used. On the personal computer. When this controller is used as a slave, the node addresses at this controller side can be selected from 0 to 126 by means of key input from the teach pendant. Baud rate 9 steps from 9.6 kbps up to 12 megabit per second can be set and an optimum rate can be selected according to the network configuration. 9 steps of 9.6 kbps, 19.2 kbps, 93.75 kbps, 187.5 kbps, 500 kbps, 1.5 megabit per second, 3 megabit per second, 6 megabit per second and 12 megabit per second can be set. Note that 750 kbps cannot be set. Input data processing. When communication error occurred, it is possible to select whether the input signal statuses are to be held or cleared when communication trouble has occurred. Connection precautions. In case this controller is terminated on the network, turn on the dip switch of the terminator terminating resistor on the Profibus board. Listed below are the possible causes of trouble. Trouble in Profibus board hardware: broken or disconnected cable, mismatched baud rate, erroneous node address setting. Caution. If an error has occurred or an LED indicating trouble lights up, the I/O statuses may not be correct. Care should be taken since this may cause the robot, jigs and other interlocks to fail to operate correctly, possibly resulting in a sudden or unanticipated operation. 1.2 The Profibus function of this controller. 1 to 4. 1.2.3 Installing location. Profibus board is in use by installing to one of PCI slot. Please remember its location slot ID number 1 to number 3, because this number needs to be set later. Number 1, number 2, number 3, slot ID. Setting screen of PCI slot ID, PCI slot. 1.2.4 Hardware. Fieldbus baseboard and Profibus module are needed. Fieldbus baseboard is incorporated with a maximum of 2 Profibus modules for use. Fieldbus baseboard. Profibus module. Module 1. Dip switch. Dip switch is not used, so does not needed to be set. Profibus module. Module 2. Profibus board. 1.2 The Profibus function of this controller. 1 to 5. Profibus module has 2 kinds. Those are master and slave. LED 1, LED 2, LED 4, LED 3. DB9 STD connector 1. DB9 STD connector 2. DB9 STD connector 1 is used for connection of the Profibus module. DB9 STD connector 2 is a serial port for setting the master module. This connector is not used for this robot controller. Note that the shape of these connectors is same. For details of LED 1 to 4, refer to Chapter 5. Profibus master module. LED 1, LED 2, LED 4, LED 3. DB9 STD connector 1. DB9 STD connector 2. Rotary switch for setting the node address is not used, so does not need it to be set. If this module is the termination of network, set the terminator switch to on side. For details of LED 1 to 4, refer to Chapter 5. Profibus slave module. 1.2.5 Cable connection. Please use a D-sub connector. Cable and the connectors should be prepared by customers. For the detail of connection, please refer to the following figure. Signal description. RxD/TXD. This pin is used to send/receive the signal. RxD/TXD and this pin is used to send/receive the signal. DGND the ground for the VP. VP this is the power supply line for the terminators. Plus 5V is outputted from the Profibus device. RxD/TXD3, DGND5, RxD/TXDN8, VP6, 3 RxD/TXD5 DGND, 8 RxD/TXDN6 VP, protection grounding, shield, protection grounding, DB9 connector. When slave module is used and this channel is the termination of network, set the terminator switch to onside. 1.2 The Profibus function of this controller, 1 to 6. Note Chapter 2 needed parts, 2 to 1. Chapter 2 needed parts. To use this function, the following optional parts are necessary. Parts, no. Product name type part, no. Recommended number of possessed parts. Remarks. 1 Fieldbus baseboard L9851B00 L9851B001. 2 Master module L9890 meters M00 L9890 meters M001. 3 Slave module L9890 S00 L9890 S001. Communication cable note, no. Product name type part, no. Recommended number of possessed parts. Remarks. L9458D00 L9458D005 meters M. 1 Communication cable L9458E00 L9458E0010 meters M. L9458F00 L9458F00. 15 meters M. Note, select one of them. Chapter 2 needed parts, 2 to 2. Note 3.1 The Fieldbus input/output signals, 3 to 1. Chapter 3 Signal allocation, 3.1 The Fieldbus input/output signals. The Fieldbus input/output signal attributes differ depending on whether the software PLC is enabled or disabled. The signal allocation positions are also determined by the numbers of the Fieldbus channels used. 2048 input/output 256 bytes of Fieldbus I/O area is divided into 512 input/output 64 bytes block. This is called channel. One or more channels need to be assigned for Fieldbus interface. Please assign from 1 channel up to 4 channels per an interface a module, according to the amount of I/O bytes for Profibus. 3.1.1 When the software PLC is enabled. If the software PLC is enabled, the signals are allocated to the Fieldbus relay inputs X1000 X3047 and outputs Y1000 Y3047. Channel number input/output number of signals. Channel 1 X1000 X1511 Y1000 Y1511 512 64 bytes. Channel 2 X1512 X2023 Y1512 Y2023 512 64 bytes. Channel 3 X2024 X2535 Y2024 Y2535 512 64 bytes. Channel 4 X2536 X3047 Y2536 Y3047 512 64 bytes. Total 2048. 3.1.2 When the software PLC is disabled. If the software PLC is disabled, the signals are allocated to the inputs I161 I2048 and outputs O161 O2048 of the general purpose input/output signals. Channel number input/output number of signals. Channel 1 I161 I672 O161 O672 512 64 bytes. Channel 2 I673 I1184 O673 O1184 512 64 bytes. Channel 3 I1185 I1696 O1185 O1696 512 64 bytes. Channel 4 I1697 I2048 O1697 O2048 352 44 bytes. Total 1888. 3.1.3 Input/output allocation across channels. The Fieldbus can use up to 4 channels. However, if not all 4 channels are going to be used, the signal allocation area of the disabled channels can be used. The description below uses a case where the software PLC is enabled as an example. Even when the software PLC is disabled, the allocation can be used under the same approach. If only one channel is going to be used, all 2048 inputs and outputs can be used by channel 1 alone if channel 1 is used. Channel number input/output number of signals. Channel 1 Channel 2 Channel 3 Channel 4 X1000 X3047 Y1000 Y3047 to 2048 256 bytes. If 2 channels are going to be used, 1024 inputs and outputs can be used by each channel if channels 1 and 3 are used. Channel number input output number of signals channel 1 channel 2 x1000 x2023 y1000 y2023 to 1024 128 bytes channel 3 channel 4 x2024 x3047 y2024 y3047 to 1024 128 bytes. The maximum number of signals that can be used per a slave/node is limited to 1664 signals, 208 bytes, for each input and output. 3.2 Profibus signal allocation. 3 to 2. 3.2 Profibus signal allocation. The head signal position is determined depending on which Fieldbus channel the signals have been set in. In the case of Profibus, the signal positions are also determined by the number of input or output bytes which has been set for the slave. 3.2.1 When this controller is used as a slave. If this controller is going to be used as a slave, the signals are simply allocated from the signal positions determined by the channels. Using a number of input/output bytes which is less than size allocated for each channel results in unused areas. Presented below is an example where 2 input bytes and 3 output bytes have been set with channel 1 as the slave. Channel number input/output notes. X1000, X1015, Y1000, Y1023 usable area. Channel 1 X1016, X1511, Y1024, Y1511 non-usable area. 3.2.2 When this controller is used as the master. If this controller is the master, the signal positions are determined by the attached configuration tool. Set the slave unit with the following tool which is to be purchased separately. For detailed method of setting, refer to help contents of the configuration tool. For the configuration, customer needs to prepare the configuration software Anybus NetTool for Profibus. This is not free. Please contact the following URL for the detail of this tool. HMS Industrial Networks. Headquarters in Sweden, URL HMS Industrial Networks. Japan branch, URL. Signal allocation. The signal allocation is determined by the numbers of the input bytes and output bytes of each slave. Given below is an example of signal allocation when channel 1 is made to serve as the master. Slave list. Slave outputs, slave inputs. Slave list sequence number, of bytes address signal number, of bytes address signal. Slave 120, 1x1000 x1015 10 y1000 y1007 slave 222 3x1016 x1030 121 2y1008 y1023 slave 314 x1032 x1039 23 4y1024 y1039 as shown in the example above. The signals are arranged in sequence in accordance with the number of bytes set and address. 4.1 Setting Procedure. 4 to 1. Chapter 4 Operation. 4.1 Setting Procedure. Shown below is the general sequence of the steps for performing the setting. Master. Hardware connections. Start. Fieldbus settings. Set the number of the Fieldbus channel to be used, the master and the slaves, and the slot ID where the Profibus board has been installed. Slave list settings. Create a slave list on the personal computer, using the attached configuration tool. Profibus master settings. Set the action to take when transmission errors occur. Reading the slave list. Read the BSS file or the DDB file created by the configuration tool. Profibus slave settings. Set the baud rate, slave node numbers, number of input/output bytes, and the action to take when transmission errors occur, and yes, no, using the configuration tool. Note. Setting procedure flowchart. Note, configuration tool is not provided. Customer needs to purchase it. When the software PLC is used for Profibus input/output signals, the software PLC settings must be performed as well. For further details, refer to the instruction manual. Software PLC. 4.2 Profibus settings. 4 to 2. 4.2 Profibus settings. 4.2.1 Fieldbus settings. Protocol settings. 1 Select constant setting -8 communication -3 Fieldbus. Following screen now appears. 2 Align the cursor with the combo box of a channel which is going to use the Profibus, and press the Enter key. Align the cursor with the Anybus Profibus using the up/down cursor key on the dialog box displayed, and press the Enter key. 3 Use the Enable and left/right cursor key to select Master or Slave. 4 Align the cursor with the slot ID combo box, and press the Enter key, in the dialog box displayed. Align the cursor with the slot ID concerned using the up/down cursor key, and press the Enter key. The slot ID is required in order to check the position where the board has been installed. 5 Align the cursor with the dialog box of the module. Input the applicable module number, and press the Enter key. The module number is a number necessary to confirm the module built-in position on the Fieldbus baseboard. If 0 is set to the module number, the applicable channel is not used. Now proceed to set the Profibus master or Profibus slave. 4.2 Profibus settings. 4 to 3. 4.2.2 Profibus master settings. Channel settings. 1 on Fieldbus settings screen. Align the cursor with a channel where the Anybus Profibus is selected, and press F key refer. The Profibus master detailed settings screen shown below now appears. To align the cursor with auto clear inputs, use the enable and left/right cursor keys, and select the signal status for when communication trouble has occurred. It is possible to select whether the input signals from the Profibus are to be held or cleared when communication trouble has occurred. Now continue to the setting of slave list. Slave list settings operation on PC. 1. Creating the slave list. Create the slave list on a personal computer, using the configuration tool Anybus NetTool for Profibus, which is going to be purchased separately. For the method of tool operation, refer to help contents of the configuration tool. 4.2 Profibus settings. 4 Operation on PC. 2. Outputting the DDB file. Select Save As. From the project menu, file save screen such as the following appears. If the file name is input and the save button is pressed, the folder of the file name input is created and the DDB file is created in the created folder. Save the DDB file in the compact flush. 3. Press F key slave list on the Profibus master detail settings screen. A DDB file selection screen, such as the one shown appears. 4. Select the DDB file and press F key OK. A DDB file is now stored in the internal memory PLSengine folder of this controller. File name is abprof number. DDB number is channel number. The screen returns to the master settings screen. 4 to 5. 4.2 Profibus settings. 4.2.3 Profibus slave settings channel settings. 1 on Fieldbus settings screen. Align the cursor with a channel where the Anybus Profibus slave is selected, and press F key refer. Following screen now appears. Set each parameter. Slave MAC ID node number is to identify a device on the network. A device with the same number in one network cannot be permitted. If this number is overlapped, correct communication is disabled. Input bytes the input byte as seen from this controller. Output bytes the output byte as seen from this controller. Auto clear inputs. Select whether to hold or clear the input from the Profibus when communication error occurs. 2. 3. If the setting is completed, press the F key OK. The screen returns to the Fieldbus settings screen. 4.2.4 Motion check. The Fieldbus monitor is used for confirming that Profibus channels that have been set are working correctly. Fieldbus monitor. 1. Select Service Utilities Monitor *, Fieldbus monitor. A monitor that shows the connection status of the Fieldbus, such as the one shown below appears. Displayed item description. *, this is the channel number. PFB. DN, this is the network type. In the case of the Profibus, PFB is displayed. Master/slave, this indicates whether this channel is set as the master or a slave. Node *******, this indicates a node slave connected to the network when the channel concerned is used as the master. In the node number is displayed. Device begin scan, the device is working correctly. Device idle, the device is not working. If the device is not working correctly, the status is displayed in a red frame. 4.3 GSD file. 4.3 GSD file. When using this controller as a Profibus slave station, it is necessary to give the information about the I/O that will be used by the slave station to the Profibus master. It is necessary to configure a slave list on a PC using a configuration software, Anybus NetTool for Profibus, and a data file to give the information about the master/slave station to the configuration software is called as GSD file. Concerning how to use the GSD file, please refer to the instruction manual of Anybus NetTool for Profibus. GSD file name. File name. Master 85 to 5093 HMS _ 18F0. GSD slave HMSB 1003. GSD. GSD files are stored in this controller, and it is possible to get them when needed. Operator class of expert or higher is necessary for this operation. Please refer to the instruction manual basic operation for the detail of copy operation. How to get the GSD file. 1. Open Service Utilities -7 File Manager -1 File Copy. 2. Set the device SRC to System and select PLSengine folder. The file name display column can be enhanced by Enable plus left/right cursor key. 3. Copy the desired GSD file to USB memory. 4 to 6 4.4 Backing up the BSS files and the DDB files. 4 to 7. 4.4 Backing up the BSS files and the DDB files. Important. If the DDB file is not restored normally, a message of E0958, the error was detected with the self-check of a communication board, will be displayed when power on. Please restore the DDB file by the procedures in the following pages or make the settings of the slave list, again referring to 4.2.2 Profibus master settings. It is not necessary to copy back up the BSS file or the DDB file with manual file copy operation because those files are automatically backed up via the normal backup operation. It is not necessary to restore the BSS file or the DDB file with manual file copy operation because those files are automatically restored via the normal restore operation. Operator class of expert or higher is necessary for this operation. Please refer to the instruction manual basic operation for the detail of copy operation. How to back up the BSS files and the DDB files. 1. Open Service Utilities -7 File Manager -1 File Copy. 2. Set the device SRC to memory and select PL-SEngine folder. 3. Copy ABPROF number, DDB file to USB memory. Number is channel number. How to restore the BSS files and the DDB file. 1. In same screen. Set the device SRC to memory and select PL-SEngine folder. 2. Copy the ABPROF number, DDB file to the PL-SEngine folder in the memory. Number is channel number. 4.4 Backing up the BSS files and the DDB files. 4 to 8. Note 5.1 What is Fieldbus release? 5 to 1. Chapter 5 Fieldbus release. 5.1 What is Fieldbus release? The Fieldbus release function is to disable the error detection for the desired slave node when this controller is working as a master node. This function is to be used when a slave node is disconnected from the network, physically because of mechanism change, etc. In the following example, the error detection for the slave 2 inches node is disabled. In this figure, if an error occurs in the slave 1, the master will detect an error. But even if the slave 2 makes an error, the error is not detected by the master node. Master, slave 1 node no, 1. Slave 2 node no, 2. Slave 3 node no, 3. Fieldbus release. Important. After the slave device is physically disconnected released from the Fieldbus, it is necessary to connect a terminating resistor on the other slave device because the terminating point will move to another place. Therefore, the slave device that will become the terminating point after the releasing operation must have a repeater function. For example, if the releasing operation is done on the position in the following figure, the slave 2 must have a repeater function. At this time, the releasing operation should be executed for the slave 3 and 4 in this robot controller. Master slave 1, slave 2, slave 3, slave 4. Releasing point. Caution. As long as the slave device is physically on the Fieldbus, it is possible to execute the I/O communication even if the Fieldbus function is released for the slave device. However, in the condition, do not leave the device released, because the communication errors for the device are not detected and it is very dangerous. 5.2 Utilizing a Fieldbus release. 5 to 2. 5.2 Utilizing a Fieldbus release. 5.2.1 How to check the current status. If the Fieldbus is released, disabled is displayed on the monitor window, Fieldbus monitor, and if there exists one or more slave devices are released from the Fieldbus, an icon of will be displayed. Status display of the Fieldbus release. 5.2 Utilizing a Fieldbus release. 5 to 3. 5.2.2 Connect/release by function command. It is possible to connect/release the Fieldbus by using FN312 fbusrel function command. Example: This is an example of mechanism change system with a tool changer. In this system, the signals are assigned like the figure shown as below. This is just an example. Details may be different depending on the actual system environments, etc. Tool, changer, external, PLC, etc. Motor, add clamp out 25, add unclamp out 26. Add clamp limit in 25. Add unclamp limit in 26. Add seating limit in 24. Add clamp limit in 25. Sub-mechanism no. 1 in 1. Add clamp out 25. Add unclamp out 26. Robot controller. Sub-mechanism no. 1 out 1. Mechanism disconnect enable out 2. Magnet SW. Motor power cable. Encoder cable. Mechanism. Profibus. Master. Profibus. Slave. Signal line. Drive unit. An example connection to the tool changer. Step N 500mm/S, Lin A1 T31. Step N +1 100mm/S Lin A1 T1 move to the mount/dismount position. Step N +2 fbusrel 110 FN 312. Fieldbus release disable the error detection. Step N +3 CHG gun 0 FN 95. Mount mechanism to make a logical disconnection. Step N +4 reset 025 FN 34. Output signal reset make unclamp operation. Step N +5 set 026 FN 32. Output signal set. Step N +6 wait I26 FN 525. Wait input and waiting for the unclamp complete signal. Step N +7 100mm/S Lin A1 T31 move to the mount/dismount position. Step N +8 delay 0.5 FN 50. Timer delay. Step N +9 wait I24 FN 525. Wait input and waiting for the seating limit. Signal. Step N +10 reset 026 FN 34. Output signal reset. Step N +11 set 025 FN 32. Output signal set make clamp operation. Step N +12 wait I25 FN 525. Wait input and waiting for the clamp complete signal. Step N +13 CHG gun 1 FN 95. Mount mechanism to make a logical connection step and plus 14 100 mm /S lin A1 T1 lifting up the mechanism from the table step and plus 15 Fbus roll 111 FN 312. Fieldbus release enable the error detection. On the step and plus 2. The Fieldbus release operation to disable error detection is executed before executing the mechanism disconnection, so that error is ignored even when the slave is disconnected physically. On the step and plus 13. The mechanism is connected, and then, after the enough time elapsed to establish the Fieldbus communication again, the Fieldbus release operation to enable error detection is executed on the step and plus 15 to restart the error detection. Parameters. First parameter, the channel number that is used by the Fieldbus master 1-4. Second parameter, the target slave node number for the error detection 0-127. Third parameter, enable/disable switch for the error detection 0 equals disable/1 equals enable. Display example. Fbus roll 130 FN 312. Fieldbus release 5.2 utilizing a Fieldbus release 5-4. 5.2.3 connect/release by manual operation. It is possible to execute the Fieldbus release operation using a shortcut R code R502. Fieldbus release. Operator class of expert or higher is necessary for this operation. Disconnecting the Fieldbus. 1. Press reset/R key. A menu window of shortcut R code is displayed. 2. Enter 502 inches or select R502. Fieldbus release using cursor keys and then press enter key. 3. Enter the channel number in which the master is set. 4. Enter the slave node number to be released from the Fieldbus. 5. Enter the number for the detection switch. 0 is disable disconnection and 1 is enable connection. 6.1 Error detection on the Profibus module. 6-1. Chapter 6 Error detection. 6.1 Error detection on the Profibus module. The Profibus master module displays the present status by means of 4 LEDs. LED 1, LED 2, LED 4, LED 3, DB9 STD connector 1, DB9 STD connector 2. LED 1 indicates the status of board. LED 2 indicates the status of database. LED 3 indicates the communication status. LED 4 indicates the status of token. LED on Profibus master module. LED and status of Profibus master module. LED color status content. Green on normal initialized and operating, green flashing clear status being cleared, red on stop stopping. LED 1. Off offline incomplete initialization, green on normal configuration data downloaded. And operating, green flashing downloading configuration data, red on database error configuration data error. LED 2. Off no database configuration data not downloaded. Green on communication / all nodes. Network in normal state communication established with all nodes. Green flashing communicating / partial node. Network in normal state communication established with more than one node. Red on communication error. LED 3. Off offline green on token held. LED 4 off token not held. Point. If there are some problems for the communication, please check the condition of the LED. Popular examples of the LED conditions and points to be checked are shown as below. LED condition points to be checked. LED 1.2.4 on green, LED 3 off. The all slave nodes are not connected. Please check if there are not any problems on the communication cables, and if there is only one slave node, please check if the node number is correct or not. LED 1.2.4 on green, LED 3 flashing green. One or more slave nodes are not connected. Please open the Fieldbus monitor and check the conditions of the node ID or cables of the node for which the scanning is stopping. LED 1.2.4 on green, LED 3 unperiodical flash in green. Check if a terminating resistor is attached at the end of the network. 6.1 Error detection on the Profibus module. 6-2. The Profibus board slave module displays the present status by means of 4 LEDs shown in the diagram. LED 1, LED 2, LED 4, LED 3, DB9 STD connector 1, DB9 STD connector 2. LED 1 is not in use. LED 2 indicates the online status. LED 3 indicates the offline status. LED 4 indicates the error status of the board. LED on Profibus slave module. LED and status of Profibus slave module. LED color status content. LED 1 off not used minus. Green on buses online network is in normal state. Data exchanges. LED 2 possible. Off bus is not online state other than online, red. On bus is offline, bus is offline. LED 3 off bus is not online state other than offline. Red flashing. 1 Hz. Error in configuration. Data. Error in configuration data. Red flashing. 2 Hz. Error in parameter. Data. Error in parameter data. Red flashing. 4 Hz. Error in initialization of the communication. LED 4. Off no error, no error. If there are some problems for the communication, please check the condition of the LED. Popular examples of the LED conditions and points to be checked are shown as below. LED condition points to be checked. Random flash of LED 2 green and 3 red. Check if a terminating resistor is attached at the end of the network. LED 3 on red, not connected to the network. Please check the following items. If the node ID is correct or not, connection of the cable, if a terminating resistor is attached at the end of the network or not. LED 3 on red, LED 4 flashing red at frequency of 1 Hz. Check if the I/O size of the slave node matches the setting of the master. 6.2 error detection on this controller. 6 to 3. 6.2 error detection on this controller. When this controller detects an error, the error messages listed below are displayed on screen. Number E0956 message communication trouble has occurred. Cause. The following causes are possible. Trouble in the Fieldbus baseboard, broken or disconnected cable, mismatched baud rate, erroneous node address setting, failure of network power supply. Remedy communication resumes when the trouble above is remedied. Number E0958 message trouble has been detected by the communication board's self-check function. Cause. The following troubles may occur. Profibus module is not installed on the Fieldbus baseboard. Profibus module is not connected on the Fieldbus baseboard securely. The slave list file does not exist or the file is incorrect. Profibus module or the Fieldbus baseboard is not working correctly. Remedy. Please check whether Profibus module is installed on the Fieldbus baseboard. Please check the connection between the Fieldbus baseboard and Profibus module. Make a setting of the slave list file. Check whether the slave file list is correct or not using configuration tool. If this error is detected, even if the Fieldbus baseboard or the Profibus module is connected correctly, hardware of the Fieldbus baseboard or Profibus module may be broken. Please replace the Fieldbus baseboard or Profibus module. Number E0959 message communication board cannot be found. Cause. The following troubles may occur. The Fieldbus baseboard is not installed. The slot ID in the Fieldbus hardware setting is incorrect. The module in the Fieldbus hardware setting is incorrect. Remedy. Install the Fieldbus baseboard. Check the slot ID in the Fieldbus hardware settings. Check the module in the Fieldbus hardware settings. If this error occurs, even if the Fieldbus baseboard is connected correctly, hardware of the Fieldbus baseboard or Profibus module may be broken. Please replace the Fieldbus baseboard or Profibus module. Number E0960 message some or all I/O links are shut down. Cause. The following troubles may occur. Failure of the Fieldbus baseboard or the Profibus module. Cable disconnection or bad contact node address setting is incorrect. I/O links are shut down. Remedy operation is automatically restored when the problem is solved. It may be necessary to turn off and on the controller power in order to solve the problem. 6.2 error detection on this controller. 6 to 4. Note.
तुझं काय काम आहे की वायरी घ्यायच्या त्याला जोडायच्या मीटरमध्ये बघायचं ओके की नॉट ओके असंच ना पोलॅरिटी म्हणजे तर येईल घे वायरी जर उलट्या लागल्या वायरी जर उलट्या लागल्या तर ते बोंब मारेल मीटर बोंब मारेल ना वायरी उलट्या लागल्या हे काही बरोबर नाही रिवर्स तू उलट्या लावल्या किंवा सिटीमध्येच वायरी उलट्या लागून आलेल्या आहेत तर तुला तिथं कळत पण तो कोण सांगणार ते मीटर सांगणार बरोबर ना एक मिनिट